Hello all, welcome to i-tutor Academy. In today's session, we will start with the Unit 16 subsection 4, that is use of autocorrelation in identifying the time series. We just begin the last video and it's a continuation of that. And while studying the correlation, autocorrelation was defined as the correlation of a variable with itself but with a time lag. The study of autocorrelation provides very valuable clues to the underlying pattern of a time series. It can also be used to estimate the length of the season for seasonality. When the underlying time series represents completely random data, then the graph of autocorrelation for various time lags stays close to zero with the values fluctuation both on the positive and negative side staying with the control limits. This in fact represents a very convenient method of identifying the randomness in the data. If the autocorrelation drops slowly to zero and more than 2 or 3 differ significantly from zero, it indicates the presence of a trend in the data. This trend can be removed by differentiating, and a seasonal pattern in the data would result in the autocorrelation oscillating around zero with some values differing significantly from zero. The length of seasonality can be determined either from the number of periods it takes for the autocorrelation to make a complete cycle or by the time lag giving the largest autocorrelation. For any given data, the plot of autocorrelation for various time lags is diagnosed to identify which of the above basic pattern it follows. This is broadly how autocorrelation are used to identify the structure of the underlying model to be chosen. The underlying mathematics and computation burden tended to be heavy and involved. Computer routines for carrying out computation are available. The interested reader may refer to Macri and Wheelwright for further details. An outline of Box-Jenkins models for time series. Box and Jenkins have proposed a sophisticated methodology for stochastic and model building and forecasting using time series. The purpose of this section is merely to acquaint you with some of the terms, models and methodology developed by Box and Jenkins. A time series may be classified as stationary or non-stationary. In stochastic model building, the non-stationary process is often converted to a stationary one by differencing. The two major classes of models used popularly in time series analysis are autoregressive and moving average models. Autoregressive model. In such a model, the current value of the process is expressed as finite linear aggregate of previous value of the process and a random shock or error AT. And moving average models. Another kind of model of great importance is moving average model, where ZT is made linearly dependent on a finite number Q of previous S, that is error terms. And the next is mixed autoregressive moving average model. It is sometimes advantageous to include both autoregressive and moving average term in the model. This lead to mixed autoregressive moving average model. So here is the equation, and the Box-Jenkins methodology is here. First one is postulate general class of models. Identifying the model to be tentatively entertained, estimate the parameters in tentative model, and diagnostic checkings is model adequate, that is yes or no. If there is yes, then use model for forecasting or control. Then again back if no, then it is identify the model to be tentatively entertained. Okay, this is the Box-Jenkins methodology. And summary of this unit 16, and this is the last unit of MMPC 005 also. If you have any doubt in this MMPC 005, you just contact us and refer our videos from unit 1 onwards. And some procedures for time series analysis have been described in this unit with a view to making more accurate and reliable forecast of the future. Quite often, the question that puzzles a person is how to select an appropriate forecasting method. Many times, the problem context or time horizon involved would decide the method or limit to choice of method. For instance, in new areas of technology forecasting where historical information is scanty, one would resort to some subjective method like opinion poll or a Delphi study. In situation where one is trying to control or manipulate a factor, a casual model might be appropriate in identifying the key variable and their effect on the dependent variable. In this particular unit, however, time series model or those model where historical data on demand or the variable of interest is available are discussed. Thus, we are dealing with projecting into the future from the past. Such a models are short-term forecasting model. The decomposition method has been discussed. Here, the time series is broken up into seasonal, trend, cycle and random component from the given data and reconstructed for forecasting purpose. A detailed example to illustrate the procedure is also given. Finally, the framework of stochastic model used by Box and Jennings for time series analysis has been outlined. The ARMA and ARIMA processes in Box-Jennings model are briefly described so that the interested reader can pursue as a detailed study on his own. So here is self-assessment exercise also from this unit. So these are all we already discussed the terms, and you just try to do it. It will help you for your term and examination and parallel with your assignment. And keyword section is also here. If you feel any words are difficult, you just refer this section and it will more easy for you. And in between any doubts you can contact us, and also you just revise the MMPC005. It will on your exams are on schedule maybe this month. So if any doubt on MMPC005, you just contact us. Next video we will start with MMPC006. And for more IGNOU MBA series, you just do like, share and subscribe our channel. And thank you so much for your support.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.